Let's step into a classroom where data tells a story and graphs bring it to life. Today, we're going to understand a very interesting problem. The question says, a dataset represents the distribution of model performance scores obtained during evaluation of an AI classification model across different batches. The grouped frequency distribution of the scores is given below. Score range, 80 to 89, 90 to 99, 100 to 109, 110 to 119, 120 to 129, 130 to 139, 140 to 149. Frequency 8, 16, 20, 26, 50, 13, 5. We have to draw a histogram for this data and then find the mode graphically using the histogram. Now imagine a real-life situation. Suppose an AI model is tested on different batches, and each batch gives a score. Some batches perform average, some excellent, and some poor. We want to know which score range appears the most frequently. That most common score is called the mode. Instead of calculating directly, today we will see the mode using a graph. That's the beauty of statistics. Now let us begin step by step. First, we need to understand that the given data is in inclusive form. That means both lower and upper limits are included. But for drawing a histogram, we need continuous classes. So we apply class boundary correction. The formula is class boundary correction equals difference between upper limit and next lower limit divided by 2. Here, the difference between 90 and 89 is 1. So correction factor equals 1 divided by 2, which is 0.5. Now we adjust the classes. We subtract 0.5 from each lower limit and add 0.5 to each upper limit. So the continuous classes become 79.5 to 89.5 with frequency 889.5 to 99.5 with frequency 160.99.5 to 109.5 with frequency 2010.9 to 119.5 with frequency 26.119.5 to 129.5 with frequency 529.5 to 139.5 with frequency 13.139.5 to 49.5 with frequency 5. Now carefully observe this table in your mind like a board in front of. Each class has equal width, which is very important for histogram. Now, among all frequencies, the highest frequency is 50, so the modal class is 119.5 to 129.5. This is the class where the maximum number of observations lie. Now let's construct the histogram. Image. Imagine drawing two axes. On the horizontal axis, we mark score class boundaries like 79.5, 89.5, 99.5, and so on. On the vertical axis, we mark frequency 5, 10, up to 50. Now for each class interval, we draw rectangles. The width of each rectangle is equal to the class width, and the height represents the frequency. So the tallest rectangle will be for 119.5 to 129.5, because its frequency is 50. Now comes the most interesting part, finding the mode graphically. Image focus on the modal class rectangle, which is 119.5 to 129.5. Now follow these steps carefully, as if you are drawing on the board. First, identify the modal class rectangle. Second, take the top left corner of this rectangle and join it with the top left corner of the next rectangle, which is 129.5 to 139.5. Third, take the top right corner of the modal rectangle and join it with the top right corner of the previous rectangle, which is 109.5 to 109.5. These two lines will intersect inside the modal class. Now from this intersection point, drop a perpendicular line straight down to the horizontal axis. The point where this perpendicular meets the x-axis gives the mode. When we observe this point carefully, it comes approximately around 123. So we say mode equals approximately 123. This means the most frequent model performance score is around 123. So what did we learn today? We learned how to convert inclusive data into continuous form, how to draw a histogram, how to identify the modal class, and finally, how to find mode visually using intersecting lines. This method is powerful because it allows us to see the most frequent value rather than just calculate it. And remember, in real-world data analysis, especially in AI and machine learning, such visual tools help us understand patterns quickly and effectively. Keep practicing, keep visualizing, and soon graphs will start speaking to you.